Okay, we're going to start off with chapter 7. Section 1 is on parabolas. Now, the equation for a parabola, if it opens up or down, it's going to look kind of like a quadratic because it is a quadratic when it's doing that. And so the equation looks kind of similar to things we've seen in the past. X minus h quantity squared equals 4p y minus k. Okay? And we're going to talk about what these different parts mean. If p is greater than 0, then our parabola opens up. Looks like a U. Okay? And so we're going to look at its graph. When it's opening up, we're going to have some different things. First thing we're going to have is the vertex. I want to make sure you can see all of this. The vertex is h comma k. And so I'm just going to draw in, let's say it's right here. Okay? Then we have something called the focus. The focus is at h comma k plus p. If p is greater than 0, then that's going to raise k up, so our focus is going to be above. And that's going to create for us a parabola that's opening upward, starting at its vertex. And opening upward. Couple other parts we need to talk about. One is the directrix. That's a new term for us, directrix. And it's a line whose equation will be y equals k minus p. So it is equally opposite direction from the focus, same distance down, but it's going to create a line that is, in this case, in the horizontal. Okay? Equal distance down from the focus. Because what makes a parabola is the parabola is a graph of all the points that are equal distance from the focus and from the directrix. Okay, so as it comes out and heads up, this distance and this distance end up becoming the same. It probably doesn't look that way with my sketch, but that's the definition of a parabola. Equal distance from this line and that point. And then the last thing we have that we need to draw in is our axis of symmetry. And that is simply x equal h. So our axis of symmetry is going up the center of the parabola sketch. Okay? And that's for p greater than 0. It opens up. If p is less than 0, then we have the exact same parts, except it's going to open down. So when we look at that, going to put in a random vertex here at h comma k. And in this case, because p is less than 0, that means that h comma k plus p is going to be below, because p is negative, so it's going to bring it down. It means that that directrix is going to be equal distance above. So this is the line y equals k minus p, but p is negative, so minus a negative p becomes a positive p. I didn't need a parenthesis there. And so when we draw in our parabola, it's going to head down. And the axis of symmetry is x equals h. Okay? Those are the parts of a parabola. And so if we're given an actual equation, we can graph it. So let's look at a couple of graphs. First one, draw a line here. Graph and state the vertex, focus, directrix, and axis of symmetry for, I'm going to give you the equation, x minus 4 quantity squared equals 8 times the quantity y plus 3. Okay, so the first thing we need to do is find our parts. Okay, for our vertex, it is h comma k. The negative's part of the equation, right? When we had the equation up here, it was x minus h, y minus k. So the vertex, the signs are the opposite of what you see in the equation. So because it's a minus 4, that means our vertex is at 4, and a plus 3 means it's at minus 3. So our vertex is 4, negative 3. So I'm going to draw a sketch over here. And I am at 1, 2, 3, 4. 1, 2, 3. There's my vertex. And now I'm going to try to zoom this in a little bit so you can see a little better what I'm doing. Okay. Next thing we need is the focus. Well, for the focus, I need P. Well, I have an 8 here. In the equation, it said that that 8 was equal to 4P. So if 8 is equal to 4P, then when I divide through by 4, I get 2 is equal to P. Okay? So for my focus, it is going to be at 4 comma negative 3 plus 2, which means it's at 4 comma negative 1. So 4 comma negative 1 means my focus is right here. Means my directrix, which is at y equals k minus p. Well, k was a negative 3 minus 2 means y is equal to a negative 5, which means my directrix is down here, y equals negative 5. And my axis of symmetry is at the x value, x equals 4. Okay, and now we draw in, starting at the vertex, our parabola heading away from the directrix. And there's our sketch. Okay? So that covers parabolas in the up and the down. The only difference between an up and a down would have been if there'd been a negative sign here on the 4p value. If that's negative, then our directrix would have ended above, our foci would have ended up below, and we would have drawn down, right? Pretty straightforward. But we know that we can also have parabolas that open up sideways. So what happens when that takes place? Well, what's happening is that instead of it being the x term that is in the quantity squared, it is going to be the y term that is squared. So it'll be y minus k quantity squared equals 4p x minus h. So in this case now, y is squared instead of x. That causes it to open sideways. If p is greater than 0, then we end up with a drawing. Our vertex is still going to be h comma k. So if our vertex is here, and our foci with p greater than 0, now the foci is adjusting the x value. So it's going to be h plus p instead of y plus p because it's opening left and right. So it's h plus p comma k. So if we're opening to the right, then p is positive. We're going to end up with a point over here, h plus p comma k. And we're going to end up with the directrix in the opposite direction. Our directrix is going to be x equals, instead of y equals now, because we're flipped sideways, it'll be x equals h minus p. So as far as we came over to the right for the positive, we're going to come back this way to the negative. So our directrix is going to be right there. X equals h minus p. And our axis of symmetry is going to be y equals k because we're now going in the opposite setup. So it's going to be this way, and that is going to be y equals k. So we end up with a parabola opening towards the foci, away from the directrix. In this case, they open sideways because it is the y term that is squared and not the x term. And that all happens when p is greater than 0, and I wrote less than 0. So let me fix that. P is greater than 0, sorry. When p is less than 0, we have it opening to the left, to the negative axis. And we'll draw one of those. Our axes. And if we start, say we start up here with our h comma k, our foci, because p is negative, will take h to the negative direction. So it's heading to the left, which means our directrix is equal distance to the right, and that is x equals h minus p. And we end up with an axis of symmetry, y equals k, and our parabola starting at the vertex, heading toward the foci, opens like that. Okay? So let's look at one of those examples. Again, we can tell the difference by which term is squared. So in this case, y plus 5 quantity squared equals a negative 12 x minus 2 in parentheses. First thing we need to do is we can find p quick. So negative 12 is equal to 4p. So that means p is going to equal negative 3, which means we are heading to the left. It's less than 0. Okay? So I'm going to draw in my axes. Okay, and we'll start putting in parts. Our vertex is going to be the x term first, so it is the opposite of a negative 2. So it's 2, and opposite of a plus 5, so negative 5. So plus 2, negative 5. Is our vertex. Our focus is 2 plus a negative 3, which means it's a negative 1, comma, negative 5. So negative 1 means it's going to be negative 1 to the left, and then negative 5 down. So there's our focus. Then we have our directrix, which is x equals h minus p. So 2 minus a negative 3 is 2 plus 3, which is 5. So 3, 4, 5. Our directrix is going to come through there. And our axis of symmetry is on the y equals negative 5. Oops, negative side's not going to show up there. Y equals negative 5. Okay? And our ellipse opens to the left towards the focus. Like so. Okay? That's how we graph parabolas, both when we have the x term squared and it's going up or down, or the y term squared and it's going left or right. Okay? Next day we're going to talk about rewriting these equations in the standard form. I'll see you then.